the different patterns or libraries or like the JavaScript things, like all the things that go on in the front end world, like which node or which tool are you using to actually just generate the front end assets? Like which one is it today? Because I sorry, I fell asleep last night and it changed.
Hello and welcome to the Sourcecraft Podcast, a show where we talk with people who are passionate about developer tools and making our lives as programmers better. My name is Beyang, and in this episode I talk with Evan Culver, an engineer whose team owns most of the dev tools and infrastructure at Segment. We talk about how to deploy hundreds of services, manage secrets with an open source CLI called Chamber, when to use serverless versus Kubernetes, ChatOps, and more. If you want to learn about how a company that's all about data pipelines manages a ton of services and helps their engineers be focused and productive, stay tuned. Evan Culver's career spans many years up and down the stack, from front end to back end to infrastructure to ops. He was an early engineer at Uber, where he worked on real-time systems and developer tools to scale the engineering organization during the hypergrowth years from 2014 to 2017. Today, he's an engineer at Segment, where his team owns most of the developer tools and infrastructure, including continuous integration, version control, cloud provisioning, secrets management, and deployment. Evan's team has a charter to empower the engineers of Segment to automate, optimize, and streamline their workflows. Evan, welcome to the podcast.
All right, thanks for having me. It's good to be here.
So the company tagline is the customer data platform that makes good data accessible for all teams. Essentially what you do is you connect all these different tools in order to make the data consistent and accessible to marketers and product managers and folks like that who want a better understanding of their users and customers. Is that about right?
Yeah, I'd say you did a pretty good job at describing it. I think when people ask me what Segment does, I try to say we take data where it's produced and get it to where it's most valuable. And that could mean a lot of things, but I guess that's one of our products. You could say that there are other things that go along with Segment as a platform, things like privacy, and we do things for GDPR, and we do things for managing personas. But in the end, it does end up being getting your data to the highest value location, whether it's any of those destinations you mentioned. But that's it.
Awesome. That is a super valuable thing to do. So that's kind of the view of Segment from kind of the outside in, as a user or customer, that's kind of the black box interface that you expose, the product level description, if you will. I'd love to get your kind of overview of Segment from the inside out, like underneath the hood, from an engineer's perspective. What does Segment look like?
Yeah. Okay. So if I was to describe this to another engineer, which I guess I am right now, it's, we're very microservice oriented. What that means is there are, developers write Go or TypeScript, JavaScript, and those, binaries or packages get produced into a Docker container, and those Docker containers run on either ECS or Kubernetes. And, in general, once deployed, they speak over HTTP and in our private VPC on AWS. We have some things running on GCP, but in general, it's mostly AWS. And yeah, I guess there's all of our application specific or segment specific containers that run. And then there's core infrastructure things like Kafka or a database here and there. We have things like Consul to do service discovery, things like that. And then, I guess there's, the component of AWS. I mean, we run everything on AWS, like mostly everything on AWS, as I said. And, I guess we tend to favor the AWS managed services, except for, things like Kafka. We run our own Kafka. But yeah, I mean, we have run our own MySQL and, MongoDB clusters in the past, but these days we tend to use the RDSs of the world or SQS or Kinesis and things like that for, the things that are in our core pipeline. So
that makes a ton of sense. For the services that you run that aren't managed services, can you walk through a couple examples of some big services?
Yeah, well, the one that is, I think, the core to it all is a service called Centrifuge that basically is our core delivery mechanism. And I'm going to speak above it a little bit because I don't work on it. I mean, it's really a great piece of software. It's gone through quite a few iterations, but it's really the brain of how messages make it through our pipeline, get redelivered, and basically are ensured the that they make it to the destination they're supposed to make it to. So whether it's this one message then needs to get delivered 3 times, once to Facebook's ad platform, the other one to Mixpanel, HubSpot. It will make sure that not only that it eventually gets there, but it will be retried if it fails initially, or that it is that retry mechanism is in a way that doesn't violate the terms of the other API provider. It does it in a friendly way, I should say. And in general, yeah, it takes care of ensuring that it's delivered. And along the way, it does this in a highly available distributed fashion. But this is a thing that we developed at Segment to do our core business. And so I'd say that service is, it's pretty important. It's not just one of those, I'd say, control plane services, and not that they aren't all pretty important. They serve their own their own purpose. But like, for example, if Centrifuge is down, like, we're like hard down. We're still accepting data, but we're just definitely not delivering any data. so that said, it's actually one of our early Kubernetes adopters. So we're just getting in on this bandwagon of the Kubernetes things and all the cloud native world. And it's generally our SREs that wrote and manage this core service. And so in being at the front of it all in terms of infrastructure and the cool kids, I guess the cool things and shiny new toys, that we're fully Kubernetes integrated there, which the other services are usually deployed on ECS. So, but I guess that's really it.
Would it be kind of safe to say that all or maybe like the vast majority of data that flows through Segment at some point flows through Centrifuge?
That is accurate. Yeah.
To kind of use the like hourglass analogy, would it be kind of the like narrow waist of the hourglass where you have like all these integrations with data sources on one side and then like all integrations with data consumer services on the other?
Yeah, I think that's probably pretty fair. I hope I'm representing this accurately. I know Ashil, one of the engineers that worked on this the most. I hope I'm representing it correctly, but he's really the brains behind all of it, and it's quite a fantastic situation that Centrifuge has put Segment in. And so, shout out to Ashil for delivering such a high quality piece of software.
Cool. So on the topic of microservices, this is a broad trend that you hear a lot about these days. It's definitely a buzzword. How do you ensure that the versions of all the different services stay in sync, and that you don't, when pushing an update to one, you don't make it so that it breaks being able to talk to others?
Yeah, I mean, how do we roll out code and ensure compatibility across all these different microservices? More or less, that's I think this is a challenge, but I mean, I think in general, our strategy is to have feature flags around as many things as possible and to do as much upfront integration testing in our pre-production environments as possible. So I think in general, like, engineers at Segment will, everybody has a pretty similar development workflow in terms of using like Docker Compose and then building things locally and just sort of their own little version of the world. But like, assuming you write your own tests and then you build your things and you've tested it locally, I think then it's introduced into our deployment pipeline. And that's kind of arm wavy because a lot of people do it differently. But in general, I think people stage their changes in a pre-production environment that might be specific to their team, or really just our staging environment in general. And what that means is we have a bunch of QA mechanisms that are kind of ongoing, where we're either shadowing production traffic, or we have a constant workload that's being shoved into that environment, for lack of a better word. And so you basically get your feedback first pretty early and often as to whether or not things are actually just working. And so a lot of times we will have an incident and it's just for our staging environment, because so we might have pushed some code that breaks one part of the pipeline or whatever. It doesn't basically makes things undeliverable, let's say. But yeah, like those things generally get caught in stage because we have pretty much a replica and a replica that's processing very production like data along the way. And then, depending on the service, I'd say there's different feature flagging components for when it does go out to production. And so, like, for example, we have depending on the customer and the sources and the destination, we have different ways of targeting these workloads as it flows through. So, for example, we have a service that will consume the messages that come off of Kafka before it gets to Centrifuge. And so there's different versions of this service that will run, and based on a flag that we set, it will roll it out to different tiers of users, so, or customers, or different sources, or there's a bunch of different combinations and flags you can set to make sure that this is the version that's actually going to be delivering and handling your code. So I'd say, like, in general, the easiest way to describe it is trying to deploy things dark and then light up new code paths incrementally as we go. And I think that there's a varying level of that in so many ways. I mean, there's some services, like, for example, because that if this thing returns in 500, a Centrifuge will then retry to deliver it anyways. Or there are other ways in which that you can there's other reliability guarantees that we have baked into the platform that, if your service has failed, it will be retried. So you basically get another chance, if you deploy some bad code. So
So you kind of design each service to be relatively fault tolerant, such that if it doesn't get exactly what it wants, or if something goes wrong like that, it is resilient to that sort of error.
yeah, I think in general, I think a lot of our services end up being stateless. So, if there is, like, if it didn't do what you think it could do, it was supposed to do, that data or that request could just be retried. And so in general, that's kind of how we treat a lot of our data plane services. Control plane services are just highly available, and yeah, they're generally read heavy, I suppose. So there's some caveats, I guess, but I didn't really ever mention that we do have hundreds of services. So for me to sort of blanket some of these things, it's with a ton of asterisks. And so I hope I'm generalizing in a way that's accurate for at least most of our services. But there are also a bunch of snowflakes, a bunch of very unique things that might be stateful instead of stateless. I didn't really even cover those, but those are usually the ones that are pretty unique. So
That is a lot of services.
oh
Uh,
man, I mean, at Uber, this was a bigger ordeal, and I think some of my former colleagues have spoken about that quite a bit. But we're talking thousands, which was a whole nother situation. I don't think I'd be the right person to talk about the way that those things are deployed. So
how
yeah,
do you even keep track of everything that's running in production at a given point?
yeah, okay. So, like, how do you keep track of all the versions, or, like, if something's broken, how do we even know which one it is?
Is there like a dashboard or some sort that gives like a bird's eye view, or is it just kind of you have to rely on the people who know the ins and outs of their part of the deployment?
I'd say that our deployment tool is kind of the best representative of that. I mean, depends on the component. So, like, some things get deployed with our internal tooling to do things that are against ECS, but and then there's other things that just get deployed with Terraform, for example. So I wouldn't say there's like one comprehensive dashboard of where all of these versions exist. Actually, I say that, and I now remember there was a service that I think somebody wrote it was just called like specs, and it was just like every service in the version that I had deployed. And I don't think that's around anymore, but it served its purpose. But what it ends up being is just like too much information for a human to really make sense out of. And so I think what it ends up being is, if you're in a big data pipeline and you have your service in the middle and maybe like five services around you, that's really the glance that you need, right? Like, my service is on version 0, that one's on version 1, that one's on version 2, and that's kind of the scope of the world you care about. So I think that in that world, it's a little bit easier to manage. Like, you really can build your own little dashboard of sorts. And I think most people, to be honest, use just like a command line tool, or they use like command like a Terraform state sort of representation to see like which version things are on. And yeah, that's that's really it. I think that it can seem really complicated, but it ends up not being very complicated in practice. But I also don't work on every single project at Segment, so I am. Yeah, that's. I'm sure I'm sure I'm just like somebody's going over Segment, just like, you don't even know I have so many services I need to keep track. It's impossible now. But there's like our feature flagging tool, which we may talk a little bit about, like how those things are managed, but those do give you some visibility into the versions that are deployed where, and also that's kind of another thing that people use to get a glimpse of all the things that are deployed.
Would it be safe to say that one of the principles here is that you don't want the global view of everything because that's too much information to consume. You just kind of want to do this look around sort of thing where you're deploying one particular service or you own that service and you want to understand like what is the current state and version of the immediate surrounding services because those are the ones that you're talking to and are talking to you.
Yeah, and I think that's probably true, and that's even if you care about the version. I guess like
Mm-hmm.
caring about the version might imply that you care about people breaking backwards compatibility, for example, maybe, or
Yeah.
I suppose that maybe there's a something to be said about needing to even answer that question in the first place if you build you know solid APIs in the first place. But yeah, I think that's probably that's I think you summarized it pretty well.
On the source, like the version control management side, are you is Segment a monorepo or do you have many different repos for the multitude of microservices you have?
Yeah. Okay. So I'd say, well, both. Just leave it. We have all of it, and we have all of them. Tons of repos. I'd say most of these microservices are in their own repositories. However, we do have some parts of the stack that are what are effectively mono repos, but they produce multiple binaries. So there's a couple I can think of. So yeah.
Cool. So in this microservices architecture, one thing that has to happen is obviously the different services have to talk to one another. And in doing that, different services have varying accesses, permission levels, things like that, and secret management becomes a thing. Can you talk a little bit about how Segment solves this problem of secret management?
Yeah. Okay. So we have this project called Chamber. I think that really is at the root of all of it. It's open source. I'd say it's pretty simple. I mean, it's backed by you can plug in different backends, but in general, we use it with an SSM backend in AWS, and
What is
yeah,
the
so
SSM backend?
systems. It is a systems. So what is it? It's like systems configuration backend. I don't even think SSM stands for the right SSM parameter store. What does it actually stand for? Systems manager parameter store. So like SSM, it's not SS. I don't know. I don't really know where the SS comes from, but yeah, it's systems manager parameter store, and that's really just you can store encrypted values in a backend. It's like a key value store for encryption.
And
So
that's the thing that Amazon AWS provides specifically for this kind of use case.
right, I'm
Got it.
looking at a page that says it provides secure hierarchical storage for configuration, data management, and secrets management. So yeah, I mean, so this it's a data store. It has some things built into it that make it more friendly for encrypting things along the way. But you can do things like use Chamber to store secrets in S3 that are encrypted manually with a KMS key. So yep, KMS is the key management system.
Got
I don't
it.
know
So
if
it can
managed
kind of hook
services.
into multiple backends.
Right.
Got
Yeah.
it.
So yeah, I'd say Chamber is at the heart of how we manage secrets. So what this means is, from a developer's point of view, you will there's a command line tool Chamber, and you'll do like a Chamber write key value, and so you might create that a key manually, or you might get one from some third party provider, and then you pipe it into Chamber to write it, and then when you're actually running your program, you use the other side of the of the tool, which is either read
Mm-hmm.
to get it out, but typically like services do this. Another subcommand is Chamber Exec, which basically takes everything in a key space and translates it to an environment variable, and then just wraps your service with those environment variables. So it makes it pretty easy to just ensure that your service is being injected with the right secrets at runtime.
Mm-hmm.
So yeah.
So the kind of user interface would be it's a wrapper around some binary that you're trying to execute. So it accepts environment variables and then forwards that to the binary executable that it's invoking, passing along the secrets that are relevant.
Yeah,
is
that's
that
right.
is that about right?
Yeah. Well, I mean, I think Chamber itself only requires some AWS credentials, so those are the environment variables that it consumes.
Mm-hmm.
But then, when it's invoked, like for example, when you run Chamber Exec, it's going to go to the backend that's configured, usually SSM,
Mm-hmm.
and then try to read for that key space all of the secrets that are there of its latest version,
Mm-hmm.
and then it takes those values and then populates the environment and then invokes the binary that it's wrapping. So yeah, I think that's basically the function that
Got
the
it.
functionality that it provides.
So
Yeah.
you
So
know.
I mean,
Oh,
yeah.
go ahead.
I guess I was just going to say that there's no real other magic that's there. Like there's other things that I think some teams use to like auto rotate their secrets and things like that. But really, Chambers kind of like the core piece that really just like interacts with the SSM backend or the S3 KMS backend or whatever. But I think there's another story to be told about how you actually then manage the versions of the secrets, which isn't necessarily what Chamber does, but in terms of just getting at the secrets, I think it does pretty simple, good job. I think what is it? With security, it's like you just want simple things to do one small thing, right?
Yeah, it's kind of the Unix philosophy.
There you go. I think our security people will be pretty proud.
Nice. So, a really dumb question. Let's say, I have an application that's deployed with Kubernetes. I have some secrets that I want to pass to the various binaries that comprise the microservices architecture. Why wouldn't I just pass those secrets directly, through Kubernetes, built-in secret support, and ultimately, as environment variables directly to the deployments? Why should I opt for something like Chamber?
That's a good question. I think that just to say up front, I think there's an open debate, especially internally at Segment, as to whether we will use the Kubernetes secrets backend, because from what I think that there was some contention around just how they're stored and the secret of the keys that are used to encrypt it and just like how those keys are managed.
Mm-hmm.
But I'm not really I haven't had that conversation, but I think in general, the idea is that no, we would want to use the secret store that's built into Kubernetes. Like why,
Yeah.
Go against the grain or try to insert some, new functionality or new dependency when, there's maybe a perfectly good solution there. So that said, if and when maybe it falls short, or maybe you want to have like, let's say, compatibility between your existing deployment environment and Kubernetes, then you might want to say, make sure that, make sure your secrets are not part of the, you don't have to do anything magical to make secrets work along the way or that doesn't break things.
Yeah.
And so what that means, I think in practice, you'd see a lot of, Docker files that are written as with an entry point that's just Chamber Exec. And so in order to run that Docker image, you would just need some base AWS credentials. And I think if you start there, then, you have a Docker image that is deployable on both Kubernetes and some other environment, right? Like as long as you're carrying along the right, or you provided the right AWS credentials that can then read that secrets namespace. So I think that might be a story for when you would not want to use Chamber, or when you would want to use Chamber across the board. But yeah, I would honestly, like for me, just personally, I would rather just use what's built in, or what's goes least against the grain.
Got it. I think that's in general a good rule of thumb to have in mind.
Yeah. I think this applies. I can think of a ton of different cases too, where this, where it's like, just use sidecars, or like, like just expose port blah, it's like, I mean, no, I really want to use this over TLS and, on a different port. And by the way, there's just like, maybe don't. I don't. Maybe like, oh no, I want to, in my health endpoints, health Z, not just health A, B, or whatever. It's like, I don't know. Maybe just use the standard one. I don't know.
Yeah.
But think of metrics, like the Kubernetes and Prometheus metric stories. Yeah.
Yeah,
Just
definitely.
expose the metrics endpoints, and then you're done.
I
So
feel like you see this sort of thing as the team grows. You have a proliferation of different practices and standard operating procedures that at some point becomes untenable.
mhm.
Before you have like a officially blessed secret management system or dependency management system, people roll their own because they need to, and then at some point you have to sit down and have that tough conversation of, okay, which one are we going to standardize on?
Yeah. I mean, it is so nice to have the Kubernetes thing be generally accepted at this point. It's pretty nice to have Prometheus in there too. It's pretty nice that we've kind of settled on a few of these solutions. And yeah, I totally agree. Yeah, there's still going like even if the community decides one thing for you, there's still going to be like all the legacy of before that, right? Like so whether it's you know I'm thinking of I'm just thinking of all the all the different patterns or libraries or like the JavaScript things, like all the things that go on in the front end world, like which node or which tool are you using to actually just generate the front end assets? Like which one is it today? Because I sorry I fell asleep last night and it changed. Like which one is it? I have no idea. Yeah, so
At some point we're just
uh,
gonna it's gonna come full circle and we'll all use make files again, right?
yeah, one can only hope. I was thinking about this in like a broader sense because, like I because it changes so often and because humans are humans and we generally have like opinions and there are things that we sort of I don't know it's we tend towards because of our history or because it makes us think less or because it's purple versus blue. It's that's fine. I feel like we're always going to have this thing. So like let's just let that happen and like but like people are going to write their code and they're going to maybe use some things to help them test their code along the way. And then that's different though when you want to actually go run your code. So like I'm kind of been toying with this idea of like, developers, yeah, do whatever you want to in your in your code repository, and then but once you're done, you're like the code compiles and it does a thing, you've tested it in a certain way, cool. I'm going to take that and just like run it, and I'm going to like run it and build it on the platform that you don't really have any say to, right? Like I'm going to give you all the resources for when it didn't do what I thought it was going to do and then give those back to you and all the information so that you can help me fix it. But like there's this point where when you have thousands of repositories and you have like across a time range where you might have had this one tool for this one thing and then it just never got upgraded, or you're using this CI provider and then the whole company switches to this one and then nobody changed that code base, so it never needed to get rebuilt, so it never got migrated. Or there's all these things where it's like you basically create giant migration stories for everybody by just like forcing them to do the work, where it's like, well, like maybe we just like let them like have their own little tooling world, and what other tools they want. But then when you actually separate the problems, right, where you have a separate problem of building the code than you do from actually running the code. And I don't know. I like the idea of saying like, okay, cool. I can see that you're using a make file, so I'm going to try to run make build.
Yeah.
Or like I can see that you're using a Docker compose file, and now I have a list of dependencies. So now I'm going to make sure these dependencies exist, or somehow like try to provision them somewhere. But maybe I won't use Docker compose.
Yeah.
Like maybe I'll I can glean the port numbers. I can glean some of the environment variables out of there. But like that's cool. I can tell what you're using to test your thing. I can probably tell maybe how to run it in a lot of ways, which and maybe it's incomplete, but then maybe let's start there and then we can plug some holes. But if no, I just like the idea of like letting developers sort of like choose their own destiny when it comes to how they want to build their code, and like let the small teams kind of be autonomous in as much of a way as possible. But then it gets a little dicey when all those things come in and say like, well, your platform that's running our code or building it needs to have dependency X, Y, and Z because mine has it. And it's like, well, like maybe that thing is harmful, or maybe that thing is, yesterday's JavaScript tool, and we're trying to use today's JavaScript tool, or something, right? Like maybe it's, or maybe it's like, hey, by the way, that thing has like super bad vulnerabilities baked into it, and we know that like that would harm small cuddly kittens if we deployed it on our infrastructure. So some like very serious things that need to happen,
Yeah.
and that's why you can't do it. So I don't know. I just thought I'd throw that out there. It's kind of just like different thing. I think because I think you can drive yourself crazy really just trying to see and understand all of the different things that people are building and shipping or
Mm-hmm.
using to ship their code. But yeah, and it's just from an organizational point of view, it gets really maddening when you're like, wait, I really wish you're on version X of Docker this just so that I can do this thing, but you're not, and so I can't. So I don't know. Just it becomes a very untenable problem
Mm-hmm.
if you're trying to enforce this all over the place instead of just letting developers do what they normally would do. So.
What do you think is kind of the role of a developer infrastructure or a developer tools team then? Because on the one hand, you want to meet folks where they are and kind of see which tools they're adopting and adjust to that. But on the other hand, you don't want everyone to adopt whatever tool they want because that causes organizational issues.
Right. Yeah. I think, okay, this is a really important question. I mean, yeah, I think this really comes down to how do you want to define your job as a tooling engineer, or really like I think it's really important just up front for there to be somebody investing in the productivity of all your engineers. And
Mm-hmm.
it's just a really important thing for organizations to do. And even if it just means we are somebody who looks at what every team is doing and then just says like, hey, there's a tool that can do generally like the 90% case to deploy code, and it's going to save you some time. But that's the starter. Like that's pretty broad. I think to answer the question in maybe a simple way, I think that there are a few things like standardization. If there's a standardization story that's important to your organization, like meaning it is important for all of us to be using this scratch image to build all of our Docker containers.
Mm-hmm.
Okay, for a security point of view, that's great. Or if it's like we all need to be on at least this patch version of this library, okay, then stuff like that, like Paul, we should be building tools and processes and procedures so that that is not a monumental effort for all of our developers to engage or to go down that path for, like, because I mean, at the end of the day, that's not productive. Like I mean, it's safe or it's what the business wants, but it doesn't help our users, it doesn't deliver value to our users. So, I mean, all that stuff is a distraction. So, what I think is, how do you build systems, you build tools in place that allow those things to have less friction. How do you just remove as many of those monumental zero sum migrations from the table up front? And I think that's really what tooling is about. Like how do we reduce the friction for just doing your day-to-day job and ultimately give developers the ability to do more developing and not like hitting enter and waiting. Like that's really what it comes down to. And that, I think that's different for every organization. Like there's maybe, you can just look at what language are you building most of your software with, and that would probably dictate a lot of what tooling works on. Or it's like, hey, how often are you doing database migrations? Like maybe you shouldn't be doing them as often. But like let's just ask ourselves, like, how often are database migrations being done? And okay, and they're probably pretty important. Okay, well, then there's probably some tooling effort that needs to be spent on making sure those things go smoothly, and just managing infrastructure maybe at some point. Or maybe you just look back and you say, hey, well, these are the things that have cost the business the most in terms of outages or issues for our customers, or maybe churn from our customers, and so it really affects the bottom line the most.
Mm-hmm.
And so that's what we want to invest our tooling efforts on. And it may be a different, I think it's different for every organization. But for Segment, I think really it is, we have a lot of, we're relatively small, I think, in terms of just number of engineers still, but I do think that
About how
we
many
are,
engineers do you have?
we're over 100. I think we're around 100-ish last I checked. So yeah, just a bit less than 200. I'm far less than 200. No, I don't think we're too much more than 100. Maybe. Anyway, but yeah, so I think we're at a kind of an inflection point where we know we're going to grow. We're never going to continue to grow steadily. So then it becomes like, how do we when we hire new engineers, how do we get them to be as productive as possible as soon as possible, and they can deliver value to our customers as quickly and as easily as possible, and they aren't sitting there spending their time going, hey, wait, how do I log into this machine and look at the file that's supposed to be there and isn't? It's like, well, all right, maybe the process we have for deploying these things is not right. So maybe we should revisit that. But yeah, so I think maybe a long-winded way of answering your question, but it's very, very nuanced. I think from from every organization's point of view.
Yeah, totally. Can you talk more about that onboarding scenario? So when you hire new engineers onto your team, how do you onboard them effectively and give them the context they need to become productive as soon as possible?
Why? So you mean tooling specific,
Yeah,
or maybe just
not
okay?
tooling or in general, like either way.
Yeah, I think well, in general, for anybody, a new engineer, I would hope that when you sit them down, you can give them like a like, let's just talk two different things. Like we talk about like they're working, their laptop's a different thing, or they're like they're working. Let's say that that's all just like dialed into their settings, and they have access to all the systems they need to, and all their SSH keys are in a good place. Fine, okay. And so now they're in like a normal square one. Okay. So, but getting it, I guess, adjusted to the code bases and the things the tooling then is like, how do we reduce this to the simplest number of things as possible? Especially like when we're talking about the number of microservices, or they're just the number of things that to keep in your head. I mean, can we just narrow that down to the smallest amount as possible for me to be productive? This is like every team's going to have a different point of view, but let's just hope that it's like I understand all the services that my thing interacts with, and I understand all the different dependencies that we have, and now I need to understand different components of the code, and then understand like how all these pieces of the code interact with themselves, and really like that might be one code base, but might also be 5 code bases, or like our team owns service X, service Y, and service Z, and like then it's sort of the same process for for each of those, and hopefully they're in the same kind of domain at least, so it's not crazy, and they're like maybe written in the same language at least, maybe, so you're not and they use the same patterns, and I think that kind of sets it all up, but it starts with the code. Like I think that it's like you sit somebody down and you say, okay, this is what our team owns. This is the source code. This is the software that we own. And so, like familiarize yourself with it. Maybe, try to fix a few bugs here and there. But then you go and you familiarize yourself with the tooling that this service or these services depend on. And that those tooling is probably how do you run your tests? How do you debug your tests? How do you build your code? How does your code get deployed? And those are, along with that, I would hope that it would end there, but I mean there's also some things too that I feel like teams at Segment are pretty autonomous. Like they end up managing a lot of their own infrastructure, with that asterisk, meaning they lean on the managed services of AWS,
Yeah,
primarily. But it does mean like, oh, I might have to install my I need to know how to install a new database schema, or I need to know like how to enable encryption at rest in my database, things like that, or to, hey, maybe just provision a new database. That's a thing. So yeah, I think that, to summarize, it's probably starts with the code base, and then goes then down the path of testing the tools used to test and then deploy, and then maybe even operate on the infrastructure. So
got it. So it starts with the source code because that's what you're going to be working on day to day as an engineer, and then you kind of walk through the entire software development life cycle to building, testing, and ultimately shipping.
Yeah, like I think that, so if I were to say that that's like our 100-person sort of point of view. Now, if you're in like 1,000-person organization with even more dimensions and degrees of which that you have to have cooperation among the platforms and the tooling,
Mm-hmm.
then it gets a little bit more dicey. I think you just become more specialized. You stop caring about how things actually get tested, and you just like hope it gets tested. And that's kind of what I was kind of getting towards, which is like, you're like, okay, like I don't have to write my Docker file anymore, right? And it's like, no, you don't, because like if you did, you'd do it in a way that wasn't satisfactory. Like it just, you don't need to. It's pointless. Like we do these things ourselves. Actually, you know what? We don't even use Docker anymore. You didn't even know, but I don't know, something crazy like that, right? Where
Yeah.
it becomes more and more specialized. I think as the size of the org grows, but you also just need more standardization too, right?
Yeah.
Like, if you're going to provide an internal build platform for thousands of engineers, it can't be snowflakey. Like it can't be like your unicorn gets run here, and all the like you get your own special instance of Jenkins, and it's like, no, I don't want to. I don't care. Just like run make test, please, and then show me the logs. Like, and just do that when I push code, please. So
Totally.
yeah,
How big was the engineering team when you first joined the team?
I believe it was in the 70s,
Okay.
70-ish. Yeah.
Okay, got it.
So
And between then and now, have there been any big changes in kind of tools or kind of best practices, code base structure, like that sort of thing, or has it been pretty stable?
I wouldn't say that like code base structure and development tools necessarily,
Mm-hmm.
but the ways in which we deploy our code has changed, and testing our code has changed quite a bit too. So we're really hoping to do more Kubernetes based
Yeah,
deployments
yeah.
soon. And I think that there are a lot of things that kind of have to change. But we're not trying to just like up in the world to up in the world. There's a lot of things we're hoping to get out of the Kubernetes integration.
Mm-hmm.
Just from like an operational point of view, it becomes a lot simpler,
Yeah.
and we have better isolation stories. And for our customers, like we have some efforts that are going on to you know create isolation at the infrastructure level for our customers.
Mm-hmm.
So I mean, you're talking about like how data flows through Segment. I mean, a lot of companies don't want their data flowing in any of the same channels that another company is flowing into. And
Mm-hmm.
so I think there's some really cool stories. Like, let's say you have your own Kubernetes cluster that's, just that's all it only runs. It runs a miniature version of Segment just in its own little world. And
Mm-hmm.
that would be cool. I think it's a little bit easier to tell that story with Kubernetes, and it's just easier to manage than it is with just like arbitrary Terraform things.
Mm-hmm.
but let's see.
How do you bridge that gap between like production and development? With the big microservices, yeah, landscape. Obviously, you're probably not going to run every single service in development. And you mentioned earlier that you have the staging environment. Is that what people rely on to kind of test things out before they push things closer to prod, or is there additional support in the development environment where you try to replicate some of that?
Oh yeah, so yeah, it just depends on the service.
Mm-hmm.
So how do you bridge that gap between, I guess, how do you reduce surprises for when you go to production? That's kind of
Yeah,
what we're
yeah,
trying to
yeah.
get at, right? So there's different. So it depends on your services, right? I mean, the service like so like let's say you have a direct dependency on some data store, and you then like, not only that, but you have like this user interaction that in order for you to test needs all this other supplementary data, right? So you need like this big complicated data fixture.
Mm-hmm.
Like there are some teams that have these very, I'd say, nuanced and complicated dependencies, and I'm just gonna leave it at that because I'm just like I'm kind of just like in my mind, like as a tooling engineer, I want to simplify and reduce the variability of all of it. But I do. Let's just say that those exist, and they're very real, and they can't write specific use cases for just these very specific things.
Mm-hmm.
Because in my world, I would just prefer you to isolate it as much as possible, and you reduce all of the variables before you go to staging even.
Mm-hmm.
But let's just say that you needed to test it in staging with some very specific data. Yeah, I think that it's just I would say that it sort of should be like a cache. You should be able to drop it and then recreate it at any time. That's kind of like a good property to have as a staging environment.
Mm-hmm.
And you'd have a way to simulate things over and over again. I think that's just another good property to have. And so if you have those two things, then cool, you can sort of have this like kind of reliable test bed. But ultimately, like if it's not production, it's not production. So you're never going to be able to completely bridge that gap. And so I kind of think that you just really have to embrace the whole incremental deployment strategy. You reduce that gap by not having a gap. So that's how I've done it in the past at other jobs. Like it gets really complicated if you always depend on, like, instead of defining your boundary just in your code very well, you instead say like, oh, I always depend on a real database connection because it's always going to be there, right? Like, well, let's just, like if that's the way you're, if you can't have very strict dependency boundaries, then then things just get really difficult to test. So,
Yeah.
or you're going to have a lot of other problems, let's say. So,
Yeah.
but
Makes sense.
yeah, so but I guess so. I think your other question was about how have things changed since I joined, just in terms of tooling and deployment. I would have to say that there's two big things really. There's the Kubernetes thing, which in my mind, like that is just, it's like a blessing. I have some qualms with some of the things that like EKS versus like GCP is offering, but that said, it's making a lot of things way simpler. And then there's the lambdas, like the serverless movement. Like before I joined Segment, there was folks working on our internal deployment tool, which does some things. It's very AWS specific and even like CloudFormation specific. But for better or worse, it does a good job of just deploying application code, but made no considerations whatsoever for deploying lambdas. And so now it's like, how do we? The paradigm's there, like for it to work with what I would hope are arbitrary artifacts and delivery mechanisms, but it's actually not that simple. So, but that's, I think, the biggest things that I see right now that have changed. I mean, other things have been relatively stable. There's always just the tool du jour for, the front end things that I don't pay attention.
Yeah. Yeah.
Not trying to downgrade, but I just don't keep up with, I think. So I'm sure that those things have changed quite a bit, but for the most part, I think, those are the two biggest shifts I've seen. Yeah.
Makes sense. So on the topic of lambdas and Kubernetes, a lot of when you listen to people talk about lambdas and also Kubernetes, one question that comes up from folks like myself who are maybe a little bit naive about the big picture is when would I use Lambda versus Kubernetes? And in your mind, is there a class of services that a Segment has that fits better into one model or the other?
I think that the emergence of Lambda is really a result of things like scheduled tasks or sort of these offline processing things, rather than like core services. So, I mean, in my experience, personally, what I've been using the Lambda tool for
Mm-hmm.
is more about like for example, I was just deploying a Lambda recently to basically do auto scaling because there's some things within AWS lifecycle hooks and things like that that just don't offer the resolution that you need to respond to things that you might want to auto scale against.
Yeah.
So there's a Lambda that checks in, that wakes up every 10 seconds and checks some metrics and then reacts,
Mm-hmm.
or does basically adjusts some auto scaling groups. But so I think that the scheduled tasks or the things that are super stateless and they just need to do one, they're super stateless. Yeah, they're just effectively stateless and they can just wake up and they don't need to build any sort of preconditions. They can just do one thing.
Mm-hmm.
And they have a very discrete set of inputs. That's really what I think Lambda is good for. I think that there's a lot of things that are really become simpler from like a infrastructure point of view too. When you talk about like how do like, let's say you can logs get ingested, so like a new file gets dropped into an S3 bucket. Well, cool. Now I can get triggered and then just process that right away,
Mm-hmm.
and I can do that in number of times based on however many things get dropped in the bucket. So it's nice to decouple
Mm-hmm.
a lot of these infrastructure components without having to do deploy a giant queue
Mm-hmm.
in the middle. And so that's another thing I've seen. But
So it is kind of the rule of thumb that you apply, if it's like a server like thing that always needs to be on, is fairly core, use binary deployed within Kubernetes. If it's something that's more event driven or like a one-off task, that's more of a Lambda candidate.
yeah, I think that it's pretty clear right away whether or not your process is like a demonizable process that needs to keep
Yeah.
some state and like keep a connection. Your state might just be a database connection. It might just be it might just be like whatever, some UDP type of thing where like it's it has a socket
Mm-hmm.
of some variety,
Mm-hmm.
or it might even be like things in memory that is just like a big data structure to make decisions, or it's building one up over time to dedupe something,
Mm-hmm.
stuff like that would probably be way better for a just like a demonizable service in Kubernetes versus a Lambda. So yeah.
Makes sense.
Yeah.
Let's chat about ChatOps for a bit. So,
Cool. Yeah.
ChatOps is kind of this idea of moving the interface for interacting with ops and infrastructure out of the traditional GUIs and CLIs that you've used to kind of introspect the state of the infrastructure, and moving more of that into these kind of like chat bots that you can interact with. Is that kind of your view of it as well, or am I leaving stuff out here?
I think that's pretty close. Yeah, I think that's like the reality is that we're spending more and more time. We're spending just as much time in our chat client as we are within our terminals or coding environments. And so, rather than go to a web page to click a button and do a thing, you might as well just like reduce the number of things you have to do those tasks within and just do it. Yeah, keep it all there. So yeah, I think that's kind of the premise. Although, I think there are some things, some workflows that are like super heavy-handed. When they're like, 12-step processes that are, like, yeah, some like, do you want to onboard a new employee? Like, yeah, provision their home directories, and like, I don't know. I'm just imagining like all these things. Like, nah, like let's just like run a script for that and like check back later or
Yeah.
something. I don't know. It's just there's things that I think maybe go a little overboard, but yeah, I think that there are really cool opportunities to just like lower the cognitive overhead or just like reduce the number of context
Yeah.
switches in this. And there's also just a cool side effect too, where if you're doing like compliance type of things, where you just need a paper trail of sorts, and as it turns out, like, yeah, going through like some change control process or whatever, it's just like you can do it, but it's like it's gonna be a pain, and like you can probably get by with just like messaging one little thing to a chatbot, and it's like, cool, I will record that this happened, and I will automatically create a commit for you,
Mm-hmm.
and then I will go and that will be pushed and then triggered on all the deployment things will take place after that or whatever. But it's
Mm-hmm.
like kind of starts with a just the lowest barrier to entry in terms of communicating that to some system. So
What sort of does Segment have chat ops like things internally that your team has developed and people find useful?
yeah, we do. I think it. If I so I'd say Segment is just like a very young, very young in the whole chat ops world. There are some things I would say that we have chosen to experiment with, and they have been great. They've turned out pretty well, and I think that there are others not to be named, but yeah, I mean there are some experiments, kind of the things that I was kind of alluding to, but it doesn't end up being that useful for chat ops or whatever. It just doesn't. People don't end up actually getting a lot of value out of it. But the things we do use it for are our SEV or incident management process. So I think early on, or at least when I joined, we were using a third party tool to manage sort of our incidents. This might be like an outage, or like, let's say, like some services degraded. You just need some like light coordination around an ad hoc, like maybe small, medium, or large emergency.
Mm-hmm.
We call them SEVs. And yeah, so like it usually involves like, creating a new channel and chat so that people can talk
Mm-hmm.
and about in a focused way. There's like, somebody gets nominated as the incident commander
Yeah.
so that they can focus on comms and just coordination. And then there's, usually an engineer or two or three that are actually investigating what's going on
Oh,
and that's
that's
causing.
really cool actually. So
Yeah.
like a
Yeah. And so, but what's cool is that, when you decide that something's happening, or, maybe you're being alerted in the first place, and, sort of lightweight discuss like, hey, everybody, this doesn't look good. Should we just call a SEV? Yeah. You just /SEV, prompts you for three things, and, you hit enter, and then, yeah, then you have a channel created for you. You have people being pinged along the way. It's sort of like asking you for updates
mm-hmm.
in a casual way.
Mm-hmm.
But what's also cool is once you're in a SEV, you can just like SEV, mitigate, or you can say like escalate. Basically, you can say like he starts at a level 3, and then if it gets more and more severe or more time goes by, then you can escalate it, and it kind of becomes more and more, I guess, prominent to the powers that be. And then so what's cool along the way is that there's these other things that kind of get created too. So like there's like an incident review for all sevs that get created that are of a certain level.
Mm-hmm.
And so then there's like some documentation around like a post-mortem that gets created, and there's just a lot of tracking and sort of like accounting that gets created, which is great for not only reviewing and understanding how often you're having these types of sevs, but also just categorizing them for the future so you can learn and really just prevent these things from happening ever again. So it's like the whole SRE mentality of kind of always iterating and always learning, and like a blameless thing. But so yeah, that's one of them. We decided to build our own because we ended up being like, we just wanted something really simple, and like all the third party things came out, and like there was always something that just didn't quite fly with somebody. They were always like, well, like I don't like it how it nags me, or like it always creates this document in this way, and we have no way to like customize a template, and it like assumes that we're going to do this and that, or it assumes we're going to have a postmortem for everything, and we maybe don't want a postmortem for anything except for sev zeros, stuff like that. And so it ends up being pretty simple. I think, shout out to Anastasia who worked on this the most, but yeah, just like coming up with a really simple solution to this, and it being what I would call a super great candidate for this ChatOps thing. Yeah, and I think it also came from just like we kind of review. I think the SREs review the process pretty regularly. Like every 6 months or so. And they're like, what do you like? What do you not like? And one of the things that they came was, I just really don't like the sev process. Our sev tooling needs this, and this. And like I think all the SREs came together and were like, I wish it did this. I wish it did that. So we had like a bunch of information as like what the ideal tool would look like. We just needed it to exist, and so it was very well defined and well scoped. And so it just seemed like, yeah, Anastasia just like knocked out of the park. So, but I could say, like, I guess I should say, like, there's a bit of an asterisk, because I'm sure that other organizations like Stripe, who I know rely more heavily on ChatOps, kind of define this thing a little bit more differently. But like, I know, for example, like they at least used to deploy code with slash commands and things like that. And there's even, I forget the level of which GitHub, the organization, integrates ChatOps into its workflows, but like the whole Hubot thing has been around for a while. Yeah, and so I think it's kind of varying levels. But we're talking like business workflows, and we're not like some of them are, well, I guess a lot of them are engineering oriented, but like the other tool I was going to mention is our feature flagging tool, which I think is generally managed by engineers. But I can imagine, like, if you're a data scientist, you might want to like manipulate an experiment, which effectively is some feature flags. And so that, you might have people that are not technical or not necessarily engineers working on these or working with these tools that eventually might be defined as ChatOps, I guess. But yeah, but I guess, yeah, that's to be, maybe it's just a little nuance that comes with an asterisk like for the very pedantic people out there. But
cool.
I don't know.
Yeah, so we're kind of coming up on the end of the time here, but as kind of a final parting question, I wanted to ask you, what are some of the new tools and technologies that you're excited about that you think the rest of us should check out?
That is a fun question. Well, let's see. I've been pretty pumped about IPFS for a while. I think that I just have faith. Like I have faith in the whole distributed internet model. I think that's gonna be cool. It's not really a tool, but it's a technology that I think is really, I think should have more attention. But in terms of tools, I really like the Knative sort of effort originally. I think it was originally called Knative. Now it's Tekton. Just the things that are going on, and like the rootless Docker building world. There's a bunch of projects. Some of my former peers at Uber done a lot of work around that. Kisu and I think was it Kraken, I think is another one. But these are just tools like manage Docker containers, like peer-to-peer Docker registries, things like that. But yeah, like I just really think that the cloud native sort of approach to doing infrastructure and sort of just describing states that what you want the world to be in, and just sort of like letting these highly available distributed systems just take care of the rest is really a fascinating thing. And I think when you kind of go nuts with it, you could even say like, okay, let's, instead of pushing to, I don't know, a Git server, I'm going to push to my Kubernetes cluster. What does that even mean? Like, no, like it's gonna speak, Git over SSH. It's gonna be sweet. And you're like, oh my god. So then like the code is gonna be in Kubernetes, and the code can get built in Kubernetes, and oh my god, like the code's it's already there, can be deployed in Kubernetes, and like it never, just everything goes to Kubernetes. It's like everything. Let's just live in Kubernetes. Like let's build our houses in Kubernetes. like let's. I don't know. It's like you can go pretty far with it, but I think it is pretty exciting to think about, like from a developer's point of view, where you offer up some custom resource types, and like maybe it's like a database thing that you as an infrastructure team have curated and you manage, and like different versions of it, but then you just give them a resource type and some ways in which you can configure it in a declarative way, and then you just let them throw that over the fence to your Kubernetes cluster, and then they get a database. Like that's kind of cool. That's instead of having to like file a ticket or like know anything about how distributed systems work, you really just like say, hey, I want a thing, and their ticket is their request or their YAML that they are shoving into your Kubernetes cluster. That's pretty neat. I think that's gives a nice separation of concerns for developers versus infrastructure folks. So super excited about that.
Awesome. My guest today has been Evan Culver. Evan, thank you for being on the podcast.
Wow, thanks for having me. It's been fun.
The SourceGraph podcast is a production of SourceGraph, the universal code search engine, which gives you fast and expressive search over the world of code you care about. SourceGraph also provides code navigation abilities like jump to def and references in code review, and integrates seamlessly with your code host, whether you're working in open source or on a big, hairy enterprise code base. To learn more, visit sourcegraph.com. See you next time.